Now, on to our next session. The most ubiquitous technology all of us use and we're connected to is our smartphones. When we pull those phones out of our pocket, the first thing we see is the lock screen. In our next session, we'll hear from Gaurav Konar and Rohit Garodia, heads of engineering at Glance, about how they use Redis Enterprise as a critical part of their platform services to deliver personalized content right to the lock screen and over 250 million customers, mostly in India and Southeast Asia. Gaurav and Rohit, take it away.
Hi, my name is Gaurav, and today we are going to speak about low latency, high QPS, gaming experiences, and ad monetization at Glance, all powered by Redis. I head engineering team at Glance for gaming, and I will shortly be joined by my good friend Rohit, who heads the engineering team for the ad monetization team. So you may ask, what is Glance? Well, Glance is the front page of millions of mobile phones. We are present across India and across Indonesia. We work with some of the most leading Android manufacturers. You name it, we work with them. But still, what is Glance? Well, we power lock screens of hundreds of millions of devices. We initially started as a thought experiment. What would happen if you could use the lock screen of a device, something that an average, a casual user looks at around 100 to 150 times a day. What if you could make that useful to them? So we started with an experiment, a thought. Let's just start giving them good, pretty wallpapers. And users liked it. They really enjoyed it. And they said, why don't you give us more? So we thought a bit more and we said, okay, if we can serve we can serve good wallpapers, surely we can serve a lot more. And that's how we really expanded upon the idea of glance and content on lock screen. And we took it to a juncture where we said, your lock screen will now be personalized with content just for you at the right time. When you lift your mobile phone, it's right there in front of your face. What do I mean by content here? What kind of content does Glance do? Well, we have news, right? One of the most obvious use cases. We show you the latest breaking news whenever it happens, real time on your lock screen. We just don't stop there. We also have live streams. All of our good creators, all of some interesting, fun content from social media, it's right delivered to you on your lock screen. We also provide you the latest happenings in the world of sports, not just as news, but even as real time scores. You want to follow the cricket match? This is the Indian in me speaking. Well, we shall serve those scores to you on your lock screen. We serve you entertainment. And this is what Glance did between 2019 to 2021. At which point Glance said, well, we seem to be covering all of these, interesting, fun content verticals, but there is this one vertical where users really, really want us to do something, and we should now take up that challenge. And that was gaming. So we started gaming as a full on destination on your lock screen, available to you every day, every moment, every minute, where we could serve you the latest fun games out there from the best gaming developers in the world right on your lock screen, where you could play them as an instant game without even having to unlock your phone. That's the kind of technology we built here. And soon, by utilizing all of our collaborations with some of the fantastic OEMs that we work with and telco partners in India, Indonesia, and Southeast Asia, we were soon able to become the largest gaming platform in these regions. We have over 75 million active monthly users. We have 25 million monthly users who come to us for live streams. We have over 400 games in our library, and these are games cutting across all kinds of genres: action, arcade, sports, strategy, turn by turn games. You name it, again, we have it. Around 40% of our audiences are women, and even they come and they enjoy playing all these kind of games, kind of breaking across some stereotypes that a lot of games are meant only for men. We have personalized game recommendations for you. We are continuing our journey of building the largest gaming library, and we want to serve each and every type of gamer, because who does not want some snackable gaming experiences? right on their phone when they're traveling, when they're taking a lunch break, or when they're between a meeting. And with this, we started a bunch of different propositions inside gaming. And today I'm here to talk to you about some of the challenges we faced as we actually went out and implemented a few of these problem statements. Today, I wish to speak to you about a couple of use cases in gaming where we felt Redis really helped us go over the bar and excite our audiences and serve them a very, very reliable and steady platform. The first thing I want to speak to you today about would be how we run tournament leaderboards for millions of users via Redis. What do we mean by tournaments? Well, they're fairly straightforward. Every day when users come onto our gaming platform, they see tons and tons of tournaments where users can go and join these contests, play a game, and these are mostly a lot of these are instant games, also called HTML5 games. They go to these games, they post a score, and then they compete around with along with the millions of users who also play on our platform. While on the face of it, this is a fairly simple problem, this soon boils down into a few complications simply because of the scale of users. We need to have always on availability of what are the live contests and tournaments in our platform. We need to have live counts of every user in every tournament and show it to every user coming on our homepage to give them a sense of excitement, to give them a sense of community, to give them a sense that they are in a stadium where they're all players on the ground. Every time a user plays a game, we have to recompute the leaderboard right away to show him his rank. Every time a contest gets over, we have to create new contests right away so that there is never a dull moment for our user. The challenges these specifically bring are the high QPS needed to show these live tournaments, the total users, and also every time a user browses the homepage, not only does he want to see what are the tournaments running, if he has already played a tournament before, he also wants to see his live rank for the tournament. A lot of this, you may say, is easily achievable by traditional SQL based databases like Postgres and so on. And in my earlier job, I had been using Postgres to run live tournaments uh, for a scale of users. But the moment we had users in those contests crossing something like 20, 30, 40,000 users, we would see enormous amounts of stress on our infrastructure. Our databases at times would get choked up. At times, we would have to kind of shut down or limit the number of participants in the tournament, not because of lack of users, but simply because our infrastructure was getting stretched. Such computation of leaderboard also ended up being so CPU intensive that we had to create batches in which we would recompute the leaderboard and never do it at real time, which was an okay compromise for the infrastructure, but a really bad compromise for the end user. And once I do remember, even today, we had a specific downtime. And the worst part was this downtime came when we had hit just our peak user base. That's the worst thing which can ever happen to you, that the time you actually have users coming onto your platform, you're unable to serve them, unable to give them a happy experience. These were some of the big issues that bunch of us found ourselves grasping with when we started to move from scale of tournaments which went beyond tens of thousands of users to hundreds of thousands of users, and very soon having a leaderboard which itself, a single leaderboard itself, having more than 1 million users onto it. How did we solve for this? Well, if you can see here, uh, we created a very simple service, couple of services. One of them we call as tournament service, one of them we call as our leaderboard service. What do these services do? Well, our tournament services, its primary job is to ensure that it maintains a live list of tournaments and contests currently running. Every time there is a tournament or a contest which gets over because the time is out, or the maximum number of people have joined, it spawns up a new contest. It also ensures that whenever users are loading our homepage, they are this is the service that we call to get all the information back, which would include, as we discussed, the specific tournaments themselves, the number of people in each of these tournaments, which, while easy to say, is much harder to accomplish if you really want to be real time, as well as uh, just keep an understanding of what all is live. This is where we started using Redis as our primary single source of truth. We had read through caching with 1 minute TTLs, which would keep refreshing the live tournaments every minute and would serve them at caches with extremely high QPS with absolutely no issues on our scale and infrastructure. We started using Redis sets, and obviously Redis has incredible data types with it, sets being one of the ones I really love, to keep a unique list of available tournaments. And every time we would see our set sizes would go to zero, we knew that was the time to create a to create a new contest on the fly without having any manual intervention. We also use Redis to create atomic counters, which would keep a real time track of how many users are currently participating in a given tournament. And trust me when I say it, nothing excites you more than on every refresh of the homepage, you can see that number going up. It gives the user a sense of genuineness. It tells the user that there are no tricks here. These are real users and they're coming every day, every minute, every second. Apart from this, we used this new leaderboard service whose primary job was to uh, you know allow a horizontally scaled set of servers to keep fetching the live leaderboard. We used the data type of sorted sets to maintain leaderboards in Redis. Every time a user would post a score, we would just add them to this data type, and the leaderboards would get recomputed immediately with absolutely no overhead on either our databases or our application servers. We also used Redis to maintain hash lists. These hash lists would contain metadata of every user so that when the actual leaderboard was fetched, we could combine on one side the leaderboard itself, which would just have user IDs, their scores, and their ranks. And on the other side, the hashes would have, for those user IDs, the names of the user, their avatar images, and then join them to give a very nice, pleasing leaderboard experience, which would be paginated and which the user could scroll from rank 1 to rank million without failing a single time. And this is how we were able to scale our leaderboards for millions and millions of users. Once again, all of this can be done via very traditional Postgres or Mongo services. However, by doing them via Redis Enterprise, we were able to do them at a scale and, most importantly, at a reliability which just ensured that we were able to focus more on the product and less on the infrastructure uptime. Moving on, we also use Redis for state management for lots of multiplayer games. In this example, I talk about one specific multiplayer game called Ludo, a very popular Indian game played by millions of users every day. What we needed to make this work was a bunch of things. First, we needed matchmaking. It's a four-player game, so you need to create rooms where you join four peoples. Um, and every time there's a fifth person, that creates a new room, and so on. We needed to do real time game updates across all clients and across all servers, given this was a turn by turn game. Again, we should never doubt the ingenuity of end users, you know, who could do whatever they can at times to kind of win or gain an extra advantage in the game. Hence, every move of the game had to be authenticated at the server side. We needed deterministic handling of error states, and we also needed pretty rudimentary payout systems. The primary challenge we faced when it came to a multiplayer game like this, once again, for a game running where you could at least have easily a few thousand parallel games running every second, was how do you deal with certain client side and server side problems. On the client side, there are always problems around network latencies, reconnections, and intermittent drops. These are unavoidable, as users might be playing these games while they're traveling on the roads, on the subways, and everything else in between. The system has to be resilient to somewhat network drops and has to provide graceful reconnects. We also needed serious scalability here. We needed a low latency single source of truth, which could then be read upon by hundreds and hundreds of servers who could then serve the end user. We needed to handle at least a QPS of 25,000 to begin with. And as I already stated, we also needed some serious reliability in the system. We could not have a situation that a single client dropping or a single client making incorrect moves would disrupt the entire game. A problem like this destroys the trust of user into the game they are playing, and then destroys the product itself, and really really hurts our retention. To solve these problems, we really dived in deep into all that we saw Redis had to offer. We primarily broke down the management of this into three separate services: the contest service, our gameplay service, and a rewarded service. The job of the contest service starts by doing matchmaking of players, whereby it allocates people in specific rooms and groups to play. From there on, it also ensures that there are always a list of live tournaments, or rather live contests running, and every time there are contests getting exhausted, it would keep spawning new contests. We then came to our gameplay service, whose primary job was to ensure that the real time gameplay, the turn by turn gameplay, was maintained along with handling all the error states and the network latencies that I spoke about. Finally, I come to the reward service, which has a fairly simple job: give a reward to the end user, be it coins, be it tokens, be it some coupons. For the contest service, we started using Redis's pub sub systems to ensure that we could have events emitted from the server in real time basis for ensuring all the matchmaking states were tracked. This meant that when a user would start joining a contest, he could see in real time as fellow users were joining on with him, and he would know in advance who he was playing against, thus never having a fear or never having a doubt whether the service was genuine or not. We also maintained timeouts via a service called Pull, which works very, very closely with Redis. You see, the problem with all matchmaking systems is this: what do you do when there is no match? Now, while we are dealing with an extremely high liquidity of users, millions of users, there are still times, say late in the night, 3 a.m. in the night in India, when there would be hardly any users on the system playing, or they would be playing different difficulties of contests. At those moments, you would have scenarios where matchmaking would fail because there were not enough people to play. Those were also situations which needed to be handled very gracefully by running timers in the background. And we use Bull and Redis to make this work extremely well. And also, as I spoke about in the previous example of tournaments, we continued using Redis Setser for ensuring we had a constant list of live games and live contests, and every time we exhausted them, we would just keep spawning the new ones. When we come to the gameplay service maintained a client server socket for broadcast of all gameplay moves. The way this would work is every time a client would make a move, it would come to our servers, and our servers would authenticate whether this move was a valid move. Once it was acknowledged to be a valid move, it was broadcast to all the other clients, all the other players playing the system via Redis's pop up systems. We also had similar problems here as we had in matchmaking, which is what do you do when a truant player just does not want to make a move? In our game, every user has 10 seconds to make a move, but there could be users who just want to spoil the game for everyone. In those cases, we had to ensure that if we did not get any event from the client and 10 seconds had passed, we would make the user skip his turn and gracefully pass the control to the next user. Again, this was maintained on our server using Bull in conjunction with Redis. Finally, when it came to doing payouts, there is always a problem with such distributed systems. What if you pay out a user twice? Even if it is coin, even if it is, a promotional voucher, you still don't want to do that. Here we were able to use Redis very, very elegantly to create distributed locks and ensure there was only one payout happening at any given time for a user playing a particular contest. With this, we were able to scale very reliably our multiplayer games. And today we have tens of millions of users coming every day, hundreds of millions coming every month, enjoying these games. And with Redis providing the reliability and the capabilities that it does, we are able to really concentrate as a team, as an engineering team, on building the product rather than maintaining the infrastructure. I would now like to hand over to my good friend Rohit to take us forward on some of the use cases in ad monetization that we have in plans.
Hello, everyone. First of all, thanks, Gaurav, for inviting me alongside with you to speak about the Glance chapter. And so, Gaurav spoke mostly about how Glance has reimagined the lock screen for millions of users and how Nostra is solving for gaming use cases for millions of users on their lock screen. So, now I'll take over and talk about how the ad monetization works. So before we deep dive into the use cases, I would just take few minutes to talk about how the entire stack of Glance native ad monetization works. So on this slide, you can see on the right side, extreme right side, there are Glance apps on the user device. There is a Glance lock screen, there is Nostra, and there are a few more apps we have like Roposo Live and Shop 101. And on the extreme left side, you can see that there are advertisers who are willing to bid for an ad slot which arise in any of these apps as an ad opportunity. And then there are various uh, systems in between. You can see that advertisers go to a platform called DSP, which is a demand side platform, and they put their bid request for a particular slot where they are looking to advertise. Then it goes through exchange, which is a marketplace where there are bids which are being used and auction happens between the advertisers and publishers. So buy and sell actually happens on the exchange. And then there are mediation platforms in between who try to optimize the ROI for the publishers or the apps so that they can maximize the yield or the revenue for themselves. And then there are third party players like MMPs, which are mobile measurement partners, who act as a referee if a same advertisers campaign are running on multiple DSPs or multiple publishers. They are the neutral parties who give the attribution to the rightful or the legitimate ad server. DMPs here notify the intelligence of the user platform where the audience targeting takes place. So now we can imagine that on the extreme right side, let's say a game is being played by a user, or the user has landed to Nostra and they are browsing multiple games and they are deciding which games they want to play with. There could be multiple ad opportunities which can arise. It could be either in the form of banner ads, it could be a very custom native ads, it could be a rewarded video, it could be interstitial. So now let's deep dive into some of the case studies or the problems which we solved uh, while looking at the entire ad monetization. I'll firstly talk about the ad serving challenges which we faced. So on this diagram, as you can see that there is a user who is from where an ad opportunity is created, and the user device is requesting for an ad. Then there is a big box in between, which is an ad serving layer, which is finally responsible for connecting to the mediation platform and then to the ad exchange, and finally to the DSPs where the actual bid has been put by the advertiser. Apart from that, this ad serving also has to do custom audience targeting. It has to personalize the ad for the user. It has to take care of various nuances about the privacy of the user and the preference, and it also has to balance out with the brand safety and the fraud checks. And the multiple hops which are there in between from system to system make it harder for us to make sure that the latency requirements end to end are met. And the latency requirements here are less than 500 milliseconds, because the moment the user has requested or the device has requested for an ad, for the user experience, for a better user experience, the ad should not result into a lag. And these are very these could be the devices where a very seamless experience for the user is required, because the user might be doing some important action, the user might be browsing through the games, the user might be playing a game while some of these ad slots appear. The user might have lost life, and they are looking to see a rewarded video so that they can be awarded a new life, or they can be awarded an extra power. So all of these could be very, very broken experience for the user if the latency requirements are not met. The other piece to talk about is that these ad serving layers get billions of requests in a day, and they also get a lot of unusually high burst kind of traffic. So that also becomes a big challenge for us. Uh, Taking an example of a tournament, there are like high stakes tournament or very high volume tournament which happen, and during that period the QPS volume of the users who are playing those games, and eventually the kind of ad opportunities which get created vary a lot. The other challenge, which is a little obvious, is that our systems have to be fault tolerant, because every ad opportunity here is equally important. If there is an ad slot and we are not able to fulfill with a legitimate ad response, it means that that inventory is lost. That is a perishable inventory, and that dollar was never made. A lot of this data which gets transferred with respect to the ad request or ad response has a very low shelf life. So you really don't need a very costly storage as such to store this temporal data. And if we talk about India in specific, the revenue per million impressions, or the CPM which is available into the market, is very, very low. Even in a lot of other markets, it's always a tough spot for getting revenue out per impression. So you can imagine that every penny we save, every cent we save for millions of ad impressions to be served, you can generate more yield per impression. So the infra budget, which is generally available for us to make our systems work at a high QPS with fault tolerance, still at a very minimum infra budget. So now let's talk about that how the Redis has helped in this journey. I'll take an example of a typical campaign. Let's say there is an advertiser who is willing to uh, reach out to 100 million users, and they want to show their ad to them at max 3 times a day with a frequency cap, so that it does not look like a spam. So essentially they are requesting for 300 million ad impressions in a day, and with a reach of 100 million users. So translate that use case into two use cases here. One is that at a campaign level, they have an impression counter. They need a impression of not more than 300 million impressions in a day, which also they need to be paced out throughout the entire day. So we use Redis for those building those impression counters and keeping that at a campaign level with a very, very high write workload. We almost operate at 250,000 plus kind of QPS. The other use case is about the frequency reach. They want to, in this particular example, an advertiser was willing to reach out to 100 million users. So it, and all of these 100 million users, they do not want to show that ad more than 3 times in a day. And that granularity could also be in an hour, or it could also extend to a week. So again, to manage the frequency counter at a user level, you can imagine that the cardinality of what we need to store is very, very high, and it almost goes to more than 200 million key value pairs we have to store. And finally, use that for capping at a frequency per user. Uh, so while there was scale and latency, cost was also a factor which I mentioned. So there are the three dimensions for us where we have to optimize. And various traditional solutions were explored, like we explored SQL, MongoDB, other databases also. However, in most of the cases, they satisfied two dimensions only. Either they can solve for scale and latency, but they are very costly, or they are like very cost efficient or sometimes open source, but they cannot solve for the scale. Eventually, we were able to find a perfect fit where Redis helped us to optimize across all the three dimensions of scale, latency, and cost. So now I'd move on to the other use case, which is about the third party attribution. So in the previous slide, we saw that why every ad opportunity is important, and finally, the ad serving has to be resilient and fault tolerant at a high scale. Now, once we have shown an ad, third party attributions, which we call as MMPs or mobile measurement partners, they act as a referee who give the attribution to the legitimate ad serving system. So this becomes even further more important that if you have shown an ad, that is a rightful dollar you should claim from the MMPs. And a lot of these MMPs are third parties, as I mentioned, because they can be neutral and they could not be biased to a particular publisher or a demand side platform. So they act as a neutral party who do a lot of fraud checks to finally award that winning dollar to the party who is closest to that. And it requires us to uh, provide all of these events, uh, which are either impression of an ad event or click events or install events and a lot of other down the funnel events. All of these need to be percolated to the third party so that they can do that matching and finally give that attribution to you. And there is a high reliance on third parties here. So while we can scale our systems, but we cannot expect all the third parties into the world to scale to our kind of uh, scale. And also, you don't want to leave any dollar on the table just because of any glitch into their system. So a use case for us emerged naturally, that how we can build a sort of a resilient rate limit system where you can store the user events per day, per hour, per minute basis, and those counters can also be stored. And then finally, it can be used as a rate limiter or a pacing solution so that the third parties can't be contacted. And finally, they give you the attribution for the ad request which you have served. Uh, so Redis uh, was again used here as a very important lever for us. We explored multiple other open sources systems also, like NGINX and few other rate limiter systems. We were almost tempted to write our own distributed rate limiter. However, once we started using Redis and finally saw that the maintenance overhead is so low, it is making us future safe. It also provides us persistence if we really want to persist some of this data for a short period of time. We found that for a few $1,000s a month, this was of great value addition for us rather than building that or using some open source and then maintaining it. So these were two use cases where the ad monetization worked well for our scale, resiliency, and making sure that the high QPS is managed at a burst traffic. So during this journey, it's very interesting, like what all we learned as part of using Redis, and I personally have been using Redis for almost like 6-7 years now. What has been a first thing is that as a developer, it has never let me down. There's so easy to get started. It leads to rapid internal POCs to be done in a fast manner. We are always ahead with respect to our adoption of various available solutions which Redis is able to provide, and a very vibrant community which you can find any answer if you get stuck. Documentation obviously is very good, where uh, there is a very quick uh, uh, any new developer who joins the team can also go very quickly to be able to adopt to the Redis journey. The second very important value for us has been that it is very, very cost effective for us. And as I was also citing in few other examples, that while in many cases some of the free open source softwares or easy managed softwares we were also exploring, but if you combine that cost with the maintenance cost and the future scalability or the rebuilding cost, we found that Redis provides us a great value for money. The third piece, which was very, very helpful for us, again, was the versatility of various capabilities which Redis has provided to us. So while the journey started with using it as a simple caching solution, and also as Gaurav was speaking, that it has evolved from that simple caching and set as a data to start using like distributed counters or using like high speed hash maps, even using pub sub operations. And even further, the journey has not ended there. We are continuously exploring more advanced features of Redis as well, like active vector databases, and so on and so forth. The fourth piece, which I also wanted to highlight, is that this is where it brings a pride to we as developers or we as a tech community, that we are future proof for growth. In fact, we are much ahead when it comes to business growth, because we are not just uh, providing them inputs, but also providing them comfort and enabling their growth, that they can confidently go into the markets and create more businesses for us. So high scalability and features like geo replication, active, and few other things make us sleep at peace, that as we expand into more geographies, we don't have to re-architect, which is something which always is back of the mind for any engineer, that do I need to re-architect my system? Is it going to take a lot of time for us? Is it going to make us the long pole when we want to grow our businesses fast? And as we are expanding glance into multiple countries, with whether we talk about US or Japan or Germany or other EU countries, including other Southeast Asian countries, we know that we are ready for embarking on that journey, and we are going to enable our business very, very strongly as a tech team. So that's pretty much from our learning perspective from Redis. Thank you very much, everyone, for listening to me and Gaurav speak about our journey and how uh, Glance is revolutionizing the overall lock screen for millions of users, and how Redis has been a trusted partner in that journey. Thank you.
Thank you, Gaurav and Rohit. It's great to see how Redis Enterprise delivers critical building blocks for a smooth gaming experience with leaderboards, matchmaking, and ad serving.